Kubernetes has emerged as a crucial tool for orchestrating containerized applications, providing a scalable and flexible framework for deploying, managing, and scaling apps. Kubernetes, also known as K8s, offers a platform that not only automates the deployment and scaling of applications but also guarantees their durability and fault tolerance. I am Balaji Chandrasekharan. Today, I'll be discussing the architecture of Kubernetes, highlighting the components and processes that enable its powerful capabilities. Kubernetes, often abbreviated as K8s, K, 8 characters, S, is an open-source container orchestration platform. It automates the deployment, scaling, and management of containerized applications. The benefits of Kubernetes are scalability, high availability, portability, security. Master node or the control plane is the starting point for all administrative tasks. The master node is responsible for managing the cluster. It schedules applications, maintains their desired state, and monitors their health. It consists of several components, including the API server, scheduler, controller-manager, and etcd. The control plane manages the worker nodes and the pods in the cluster. In production environments, the control plane usually runs across multiple computers and a cluster usually runs multiple nodes, providing fault tolerance and high availability. The API server is a component of the Kubernetes control plane that exposes the Kubernetes API. The API server is the front end for the Kubernetes control plane. The main implementation of a Kubernetes API server is kube-apiserver. Kube-apiserver is designed to scale horizontally, that is, it scales by deploying more instances. You can run several instances of kube-apiserver and balance traffic between those instances. Consistent and highly available key value store used as Kubernetes backing store for all cluster data. If your Kubernetes cluster uses etcd as its backing store, make sure you have a backup plan for the data. You can configure etcd externally or even make it a part of the Kubernetes master. Control manager is known as a controller, and it's a daemon that adjusts the Kubernetes cluster. It runs on the master node and is responsible for managing various controllers that regulate the state of the cluster. Each controller is responsible for ensuring that a specific aspect of the cluster's desired state is maintained. Control plane component that runs controller processes. Logically, each controller is a separate process, but to reduce complexity, they are all compiled into a single binary and run in a single process. These controllers continuously reconcile the actual state of the cluster with the desired state specified in Kubernetes objects, such as deployments, services, pods, etc., ensuring that the cluster remains in the desired state despite any changes or failures. The kube-controller-manager implements control loops for each controller, periodically checking the cluster state and taking corrective actions as needed to maintain the desired state. Scheduler watches for newly created pods with no assigned node, and selects a node for them to run on. The scheduler is responsible for assigning workloads to specific nodes in the cluster. Factors taken into account for scheduling decisions include individual and collective resource requirements, hardware, software, or policy constraints, affinity and anti-affinity specifications, data locality, inter-workload interference, and deadlines. Worker node runs apps via pods, and master node controls the pods. Pods are scheduled on a physical server, slave node. So when you want to access the apps from an external environment, you'll have to connect to these nodes. Each worker node contains components necessary for managing the containers. Kubelet is an agent that runs on each node in the cluster. It makes sure that containers are running in a pod. Kubelet communicates with master node and executes on worker nodes. It obtains pod specs via API server. The kubelet takes a set of pod specs that are provided through various mechanisms and ensures that the containers described in those pod specs are running and healthy. The kubelet doesn't manage containers which were not created by Kubernetes. A fundamental component that empowers Kubernetes to run containers effectively. Worker node requires a container runtime to manage and run the container's life cycle. Kubernetes supports container runtimes such as containerd, CRIO, and any other implementation of the Kubernetes CRI, container runtime interface. Docker is often confused as the container runtime, but it's a platform that utilizes containers in this manner. Kube-proxy is a network proxy that runs on each node in your cluster. Kube-proxy maintains network rules on nodes. These network rules allow network communication to your pods from network sessions inside or outside of your cluster. Kube-proxy uses the operating system packet filtering layer if there is one and it's available. Otherwise, kube-proxy forwards the traffic itself. Add-ons use Kubernetes resources, daemon set, deployment, etc., to implement cluster features. Because these are providing cluster-level features, namespaced resources for add-ons belong within the kube-system namespace. A pod is the fundamental unit of deployment in Kubernetes. It represents one or more containers that are tightly coupled and share the same network and storage resources. A pod contains a unique network ID, application containers, and storage resources to determine how it'll run containers. Pods can easily suffer a change. Therefore, Kubernetes can't assure that a physical pod will remain alive. The service will display a logical set of pods, but it will also play the part of a gateway. The pods will be able to send requests to the service. The most meaningful benefit that Kubernetes deployment brought to us is the automation system regarding various repetitive functions, scaling, updating in production applications, deploying. Additionally, the automatic pod instances launching mechanism provides you with a peace of mind, since now you can rest assured your instances will run as intended and across all nodes within the cluster. In essence, the more automation you have, the better. You'll also experience fewer errors even though your deployments are much faster. We've reached the conclusion of this session and look forward to seeing you in our next one. We hope you've enjoyed the video. Don't forget to like, share, and subscribe. Thank you for watching my video.